Welcome back to our next lesson on factoring polynomials. Today we are going to learn how to factor binomials, these special type of binomials. We'll learn about them in a minute. But first, let's review what we know about factoring out the GCF. So I'm going to start by looking at the numbers 8, 24, and 12. And I have to think to myself, what is the greatest common factor? What is the biggest number that I could divide out of each of these terms? And I know it's not 8, because 8 doesn't divide by 12, but 4 does work. So 4 works, and now I have to think of my variable. I take the x, since they all have an x, and I choose the smallest exponent. So x to the 5th, x to the 5th, and x to the 5th. So my GCF is 4x to the 5th, and now in parentheses, I'm going to put what I get from dividing. So negative 8 divided by 4 is negative 2. Then we have x, 7 minus 5 is 2. Then put our plus, 24 divided by 4 is 3. Then we have x, 6 minus 5 is 1. Then plus, 12 divided by 4 is 3. And then x to the 5th divided by x to the 5th, they just cancel out because we have x to the 0, which would give us 1, and 1 times 3 is just 3. So this would be how we factor out the GCF. We're going to eventually learn how to also factor trinomials, so maybe there is something more we can do with that trinomial in the parentheses, or maybe it's not factorable, but we'll learn about that in the upcoming lessons. Let's look at this next one. So what can we take out of 50, 50, and 20? I know I could take out 5. Is there anything bigger? I can't take out 20. 10. 10 works. And I'm not going to be able to take out a p because each thing here doesn't have a p. So my GCF is just 10. 50 divided by 10 is 5. Leave the p to the third. Then 50 divided by 10 is 5. Leave the p squared. And then negative 20 divided by 10 is negative 2. And this is my final trinomial. Alrighty. So let's get into how we are going to factor these perfect squared binomials. What is a perfect square binomial? First, let's learn how to multiply these. Let's just review it. 8x times 8x gives us 64x squared. 8x times 4 gives us 32x. Negative 4 times 8x gives us negative 32x. And negative 4 times 4 gives us negative 16. Which ends me up with 32 minus 32 just goes away. So I would have 64x squared minus 16. Something special about this 64 and this 16 are they are both perfect squares, because 8 times 8 equals 64 and 4 times 4 equals 16. So today we are going to learn how we can be given this as a problem right here, and they could tell us to factor this, which then we would go back to this answer right here. So if we kind of think about what I said before, the square root of 64 would be 8, and I see two 8x's here. And the square root of 16 would be 4, and I see two 4's here. And in the middle, I see a minus and a plus. So that's how it's going to work today. So let's just have you do this one quickly. Pause the video and try this one. Alright, so hopefully you paused the video and tried them. Alright, so 7a times 7a is 49a. 7a times negative 3 is negative 21a. 3 times 7a is positive 21a. And 3 times negative 3 is negative 9. So again, the negative 21 plus 21 just cancels out, so we'd be left with 49a, which 49 is a perfect square, minus 9. And the square root of 9 is 3 and 3, which are our 3's in our original answer. So again, today we are going to learn how to go from this product that we found back to the factors. So, notice and wonder, what do you notice about both of these problems and their answers? We kind of talked about it already, but if you think about it, the square root of 64 is 8 and 8. And the square root of 16 is 4 and 4. And then there's just a minus and a plus. And if we think about going the other way, if I do 7a times 7a, I would get 49a squared. And 3 times negative 3 gives me negative 9. I don't have to worry about those middle terms because as we've seen in both of them, when you multiply the middle terms, they end up just canceling out. Because one would be the negative version of the same number and one would be the positive version. Alrighty, So let's just remember the perfect squares. Those are all the perfect squares numbers. We learned that back in the first unit when we were going over how to simplify radicals. So what is a difference of perfect squares? That's whenever we are given two numbers that are squares and there's a minus in front of them. In order for a variable to be considered a square, it has to have an even exponent. So x squared is a perfect square because in front of it is a 1. 1 is a perfect squared. And x squared is a perfect square because it has an even exponent. And then 16 is a perfect square, and then we have the minus in front of it. That's how it gets the name, the difference. Difference means minus of perfect squares because both numbers will be a perfect square. And how we are going to write our factored answer is we're going to have two sets of parentheses where we're going to take the perfect square of both terms, write them down, and then put a minus and a plus. So this one right here would not be able to be factored because it has a plus sign. There's no way that we can do x plus y, x minus y, and end up with this negative y squared. No matter what combinations if we do, we will not end up with that negative y squared. All right. So factoring the difference of two perfect squares. 1, both terms must be perfect squares, and you must have a minus in between them. First, with all factoring techniques, you want to make sure that there's no GCF, and if there is, you want to factor that out. Then you want to use two sets of parentheses where one's going to have a minus sign and one's going to have a plus. And then you split up what it takes to make the first a perfect square and what it takes to make the second a perfect square. So let's see what all of this means. Examples. Right here, I know that the square root of 36, if I did this in my calculator, the square root of 36, let me clear out my calculator, the square root of 36 is 6, and the square root of x to the fourth would be x to the second. You just divide the exponent by 2. And then the square root of 9 is 3. So you write your final answer as, what is the square root of 36 x to the fourth? Well, the square root of 36 is 6, and the square root of x to the fourth is x to the second. Then you put your minus and plus, and then you ask yourself, what is the square root of 9? It is 3 and 3. Let's look at this example right here. Square root of 4 is 2, and the square root of x squared is just x, because 2 divided by 2 just gives you the 1. Then the square root of 81 is 9. The square root of y squared is just y. And that's where we get our answer, 2x and 2x. Then you put a minus and a plus, or a plus and a minus, doesn't matter the order, and you put your 9y and your 9y. All right, let's do our first example. What is the square root of 9y, k squared? The square root of 9 is 3, and the square root of k squared is 2 divided by 2 is just k, 1. Then the square root of 4 is 2. And now you write your final answer as two parentheses, one with a minus, one with a plus, and then put both terms. And one thing I forgot to do at first is you wanted to make sure there was no GCF that you can take out of here. So I can't take out 4, 3, 2, 1. I could take out 1, but that would just not help us make it any simpler. And this is our final answer. This is the factored form. If you went to multiply this and find the product, you would end up with our original answer. Let's look at this problem. What is the square root of this, and what is the square root of this? First, make sure there's no GCF. I know there's no GCF here because our lowest number is 1, and we can't, taking a 1 out would not help us simplify it. The square root of 64 is 8. The square root of z squared would just be z. And the square root of 1 is 1. So we would have 8z minus 1 and 8z plus 1. Or you could put minus plus, plus minus, doesn't matter. And this is factored form. You can check it by multiplying and you would end up with our original answer. So now I want you all to pause the video and try this one. First, you have to ask yourself, is this a difference of perfect squares? Well, let's see. Are those both perfect squares numbers? 16 is a perfect square. 25 is a perfect square. But I also want to first make sure there's no GCF I could take out. So I'd look at my smallest number, which is 16, and write down the factors of 16. 2 and 8, 4 and 4. I know 25 does not divide by 16, doesn't divide by 8, doesn't divide by 4, doesn't divide by 2. So there is no GCF here. Technically the GCF is 1, but 1's not going to help us. But we are lucky because these are both perfect squares. So square root of 16x squared would be 4. The square root of x squared is just x. And the square root of 25 is 5. So now we write down 4x plus 5 and 4x minus 5. And that is factored form. Alrighty, now can we go ahead right now and say that this is the difference of perfect squares? Well, what is the square root of 100? And what is the square root of 16? Yep, they are both perfect squares, but I would be left with the numbers 10 and 4. And I know there is a number that I could take out of 10 and 4. I could take out a 2 out of them. So I'm not going to go ahead right now and start taking the difference of perfect squares. I'm first going to see if there's a GCF. So let's see. 16 is my smallest number. Let's write down the factors of 16. 1 and 16, 2 and 8, 4 and 4. Remember, if it's not easy for you to get those factors, you can go to the graph. Type in the number you're trying to get the factors of, 16, and divide that by x. Then go to your table. And if you see right here, our factors are 1 and 16, 2 and 8, 4 and 4. All right. Now let's go back and see what is a factor of 100. 100 doesn't divide by 16. Nope. 100 does not divide by 8, but 100 does divide by 4. All right. So our GCF here would be 4. We wouldn't have any variable since both terms don't have a variable. So we'd have 4. 100 divided by 4 is 25, x squared. And bring down the minus. 16 divided by 4 is 4. Now, let's make sure this is still a difference of perfect squares. Is 25 a perfect square? Yes. And is 4 a perfect square? Yes. All right. So we're going to have two different set of parentheses. One with a minus, one with a plus. The square root of 25 is 5. And then the square root of x squared is just x. And the square root of 4 is 2 and 2. So this right here is called factoring completely, which we're going to do a whole lesson on, but this is a preview into it, where you first have to take out a GCF, and then you continue your factoring. So it's only the simplest answer if you look inside those binomials, the things with two terms, the 5 and the 2, and we know there's no number I can take out of 5 and 2 evenly. Let's look at this one, 18 and 128. Let's write down our factors of 18. We could have 1 times 18, 2 times 9, or 3 times 6. Let's see, does 128 divide by 18? It does not. Does 128 divide by 9? Nope. 128 divided by 6? Nope. 128 divided by 3? 128 divided by 2? Yes, that works. So I'm going to take a 2 out. I can't take any x's out since both terms don't have a 2. So my GCF is 2. 18 divided by 2 is 9x squared. And 128 divided by 2 would leave us with 64. Now we need to make sure these are the difference of perfect squares. It is the difference because I see the minus. And they are perfect squares. So the square root of 9 is 3. So I'd be left with 3x and 3x. And the square root of 64 is 8 and 8. Alrighty. That is factored completely. And in this case, we could not start this problem by doing the difference of perfect squares first because 18 is not a perfect square, and I don't think 128 is either. So we literally couldn't do the difference of perfect squares yet. We had to factor out the GCF in order to be able to do that. And let's try factoring this last problem. Zaire went to the... this might not be our last problem. Let's try this. Zaire went to factor 9x squared plus 16, and her answer was 3x minus 4 and 3x plus 4. Is her answer correct? Let's see it. I'm going to try multiplying and make sure that I ended up with the same answer. 3x times 3x is 9x squared. 3x times 4 is 12x. Negative 4 times 3x is negative 12x. Negative 4 times 4 is negative 16. Well, 12x minus 12x would cancel out, leaving me with 9x squared minus 16. Ooh, but her original problem was 9x squared plus 16. So was her answer correct? Her answer is not correct. She tried to use difference of perfect squares, but did not have a minus. There was no minus originally, so she couldn't do that. You could only take the perfect square of both terms when there is a subtraction sign. There, she did not have a subtraction sign. All right, and a blast from the past. This is just really quick. I want us to be able to draw a sketch of what the following types of graphs look like. So what is the graph of just x? Let's see. A graph of just x. This is called linear, would look like this. Or it could end up looking like that, because it could be negative or it could be positive. The other one that I showed you is the graph of negative x. All right. Now, what is the absolute value graph? We should know that the absolute value, v value. So that is the absolute value graph. What does an exponential function look like when we have an exponent as our variable as our exponent? Let's see that right here, 2. Oh, where's my little caret key, x? What does that look like? It looks like a curve, like that skateboard ramp. And we haven't learned if this is exponential. We haven't learned about this one yet, but this is what our next unit is going to be on. What happens when we have a 2 as our exponent? It ends up looking like a U shape, and we're going to call that U shape a parabola. And this is called a quadratic. So these are the 4 different graphs that we are focused on. We really want to know about linear. Linear is a straight line going up or down. Absolute value is a V shape. Exponential is that little skateboard ramp. And quadratic is whenever we have a U shape. And that sums up our lesson today on the difference of perfect squares. Remember, in order for something to be a perfect square, a difference of perfect square, you must have 2 perfect squares and a minus sign. Alrighty, that's it for today.